That's not helpful. All right, let's share. Okay. All right. And I'm sharing screen. Here we go. So we're looking at that worksheet, and I have it open over here so I can just do a little bit of a sample. Okay. So once this starts sharing, then I will start. Because there were a few different sections, I'm going to do a couple from one for the first two sections, and then I'll continue here. And I just want to get it so I can see you guys first. Let's see. All right. All right. Let's see what we have. All right. So let's look at this. This is that one worksheet. This is 1.2.3 worksheet, right? And this was just looking at our exponential equations. We're going to create exponential equations. So the main thing for this, the main thing is to write this equation down, because this is our main equation. Okay, 1 plus or minus rate to the x. And it might look, when you're doing these problems, like there's so much information to put in there, but there isn't. There isn't. This right here is our initial amount, right? And you may have seen this term here. This is our zero term. Zero term. Okay. The zero term is after zero amount of time has gone by. Okay. So I know that when zero time has gone by, I'm at my initial amount. We haven't had any growth or decay. It just started. Okay. Here's our rate. That might be growth. It might be decay. And this is our time. Okay. So these are the three elements that we're going to keep coming back to. The other thing that I'll just bring up, because it's listed this way, is that we look at this right here as our multiplier. Okay. And based on if it's a growth, we add, right? So 1 plus any number is going to be greater than 1. So when we have growth, we add. When we have decay, we subtract. So 1 minus any number is going to be less than 1. So we can already make another rule right here that when we have, I'll do that rule later when it comes up. But let's look at number 1, because number 1 through 4 is just asking this. It says, just determine the multiplier. So we're looking for the multiplier. Whoops. This is like a baby step for doing the other problems. You'll see that this is going to be a really quick step after we see how 1 goes here. So we have 5% growth. I know we're looking for the multiplier, so we're looking to see what value we'll get in our parenthesis after we plug in our growth rate. So watch. What is 5% as a decimal? 5% of $1 is how many? 5 cents. Okay. So first you just change it to a decimal. We know that it's growth, so within the multiplier, I'm going to bring that down. This is going to be 1 plus, because of growth, I know it's plus 0.05. So my multiplier, 1.05. Done. How did I do it? We had a percentage, I changed to a decimal. We had growth, so I know within my multiplier, I'm going to add, and I add the growth as a decimal, 1.05, $1 plus 5 cents. Okay. Thumbs up, sideways, down. Do you see how we're doing numbers 1 through 4? 1 through 4, okay? Okay. I'm going to do, good. I'm going to do the next one kind of like super speed here. So we'll just go, number 2 has 12% decay. So again, we're looking at our multiplier right here, and I know 12% is 0.12. I know decay means that I'm going to have subtraction. So it's always 1 minus, if it's decay, 1 minus our rate. So altogether, we're going to get 0.88. That's our multiplier. All right. All good? Yeah, I think we get that one, right? It was just like, what are they asking? That's what we had to think about for a sec. All right, I'm going to try to do, so it's all on one page and keep it together. I'm going to look at this, number 3. Now, here's the thing. You saw this f of x, and it might have confused you, and that's okay. Because f of x, this is just function notation. We'll learn about that next month. But we can go ahead and know that f of x is equal to, it's the same as just y, okay? In this time of the year, f of x is function notation. We don't have to use that. We can just substitute it in for y. We can just say f of x, that's just y. It's a way to express in function notation, which we'll get to. But hey, as long as you know, hey, you're going to start right here. then you're good. And what we're asked for in this is, tell me if this is growth or decay. That's what we're asked. So we want to look at one important thing, because this 3, right? This 3 is the multiplier. We combined some rate, 1 plus or minus some rate, to get the multiplier. So here's what I want you to think about here. If you have 1 and you add, that means you're having growth. When you have 1 plus, that means you're adding some rate, because you're adding the multiplier, you're making it larger. If it's 1 minus some rate, then you're subtracting 1 minus, because it is decay. Okay, so you want to look at this. How would we get 3 in here? What would we have to do? 1 plus a number or 1 minus a number? Can you do 1 minus a number and end up with 3? No. You have to do 1 plus a number, right? So anytime, this is how we're going to always look at this. Make a star right here. Make a star. If you know this on the quiz, you're going to definitely get these problems. Make a bunch of stars. Because we know it's growth. We know it's growth if the multiplier is greater than 1. Growth. We know it's decay if it's less than 1. Okay? So it's growth if the multiplier is greater than 1, because that means we'd have to add within our multiplier, we'd have to add the rate. That makes sense, because growth means adding. We know it would be less than 1 if we subtracted it. So if the decay is 1 minus some rate, then we'll always end up with negative or less than 1. Okay. So with this, all we have to look and see is 3. Is that greater than 1? Yes. So this right here is growth. So is it greater than 1? Yes. So it's growth. And that's our answer right there. Okay. Growth. So, I'll just do number 4 right below it, because it's going to be excuse me, that wasn't number 3, that was number 5. That was number 5. All right, so now we're going to do 6, not number 4. We're going to do number 6. All right, so for number 6, we have this situation. We have f of x is equal to 0.25 raised to the x. So I can just rewrite that in regular 2-variable notation here. Y is equal to that base raised to the x, right? So then you want to look at that and ask, well, growth would be if it's greater than 1. Decay is less than 1. So what is this going to be? Pretty straightforward. Is it greater than 1 or less than 1? You got $1? No. Yeah, so it's decay. Right? Right? Evie, good? Yeah? Okay. All right. That's good. Okay. So let's see. Like for number 9, the multiplier is 5. So if the multiplier is 5, in here it was 5, it's going to be growth. For number 10, the multiplier is 1/2. So if in here is 1/2, it's less than 1, so it would be decay. That's it. All those ideas are connected, so we'll just leave it at that. I think that's good to see 2 different problems like this. Okay. Now, let's do one of the word problems. Does anybody have one of the word problems they really want to see really badly? I could just do a couple. Yeah, I'll just do a couple. I'll do number 11. All right. Okay, screenshot this if you need to. Screenshot this if you need it. Okay. Do a screenshot real quick. If you keep a folder on your desktop, screenshots for Math 1, you could throw them all in there pretty quick. Good job. All right, here we go. Let me know at the end if you need me to put that up again. Let's look at number 11. So 11 is one of our word problems, but it has those steps for us, and all the problems that we just did are kind of the steps we'll do. So let me write down what we have. Movie tickets looks like are $9.75. All right, let's see. They're increasing by 15% a year. Now, is increasing growth or decay? Increasing? Yeah. I mean, it's up, right? It's growth. So we know this is growth. We already have like so much information here. How much will they cost in 5 years? So cost in 5 years. So look what we have. we have our initial amount. That's our A. We know that this decimal with growth is going to end up giving us our rate. And we know this is our time, which I've been loading as X. So now if we look here, 1 plus or minus R to the X. We're going to start with that same equation every time. All right, let's plug in what we know. Y is equal to 975. That's the starting amount. 1, okay, it's growth. So plus or minus growth. Growth is going to be, yep, good. Plus, and we got to put this as a decimal. So 15%, it's 15 cents. Just start thinking as cents. Because 1 cent is 1/100th. A cent. Cent is the prefix for 100, right? So century, right? So 1% would be 1 cent. 15% is 15 cents. Okay. So we're going to go 0.15. How many years? 5 years. Everyone feel confident they can plug those in there? Feel pretty good? You look for 3 things, right? 3 things. Remember, there's only 3 things. Initial amount, the rate, which we could figure out. That's probably the most complicated in here, but they're easy questions. Growth or decay, put it as a decimal atom, and time. So initial amount, the rate, and the time are the only things we're looking at. All right. I want everybody to have their calculator out because I don't want you to get to the quiz and realize you're in the wrong mode or something. So I want you to try to do this problem on your calculator. And I'll do it as well. Throw your answer in the chat when you're done. Let's see if we can get it. Whoops. All right. All right. I got my answer. What do you guys got? Noah, perfect. Good job. Who else has an answer for me? Remember, it's cents or it's money. So give me an answer that is money, right? So we don't round to the 10th. We don't do anything like that. We give the whole amount to the hundredths. All right, Eliana, you got it. Evie, you got it. Perfect. All right, so we're good with the calculator. Ava, don't be questioning. You got it. So sometimes you just got to like do it in the calculator to say, okay, I know I'm pushing the right buttons. Like honestly, that's like half of the work with these kind of problems is getting the calculator right. So good job if you did it. Good job. You're going to see, I'm going to do the next problems. You're going to see that it's going to be the same process. So let's see if we can do number 12, unless anybody wants me to slow down. Anybody need me to slow down? Okay. Number 12. All right, number 12. A powerful computer is purchased. So our initial purchased, our initial A is going to be $2,000. Maybe start even writing them down, these bullet points on what you're looking for. Okay. Let's see. Loses 20% each year. Loses is talking about growth or decay. It's talking about decay, right? Because you're losing it, so it's decaying. It's becoming smaller. Lastly, how much does it cost? Cost in 4 years. Okay. So I'm going to rewrite the equation just so you can see it over and over and over and get sick of it. Dream about it. Can't stop thinking about it. All right. So exponential equation here. Let's do some of the work right here first. Oh, I guess we have letters to answer. Let's do it. I don't know if those are... Oh, that's fine. Let's answer. I didn't do it for number 11, so I'll do it here. Let's answer these questions, and then we should be able to do it. Growth or decay? Growth or decay? We already said it's going down. It's losing 20% a year, so we know it's decay. Okay. B, what is my multiplier? Well, let's look at remembering that the multiplier is everything in the parentheses. The multiplier is in the parentheses. So when I go to this, I can go ahead and just bring down what's in the parentheses. I know it's decay, so I subtract. Right? All of these are baby steps. Number 16 we'll do next, and that's none of these baby steps, and you'll see maybe it's even easier to understand. Let's put 20% as a decimal. 20% is 20 cents. So I'm going to put that right here. So for B, I get my multiplier is going to be 0.8. You see how it's just asking you to do the baby step? All right, don't get confused by that. It's fine. It's fine. All right, for number C. For letter C, it's asking is 2,000 your zero term or first term? Remember that the zero term equals the initial amount. So was 2,000 our initial amount? 2,000 was our initial amount. The first term would be after one time interval, right? So the first term, zero term is what you start with. First term is after a certain interval. Second term is after another increment of interval, and so on. So with this, is 2,000 the zero term? Yes, zero term. All right. That's like a little baby question. Oh, how's the question? You have the answer already. Oh, you're way ahead of me. I haven't even started. All right. Write the equation. All right, now we can do it. So let's write it here, I guess. Initial amount, 2,000. Actually, we've done this, but I'll write it again. 1.20 raised to the, how many years? 4 years. So let's just simplify that. Okay, I want to bring up this work that you're seeing right here as I'm solving this equation. I need to see that work, guys. I need to see the work because I can't tell if you're doing mental math. I can only kind of like look at what you're doing through what you submit. So if you're doing kind of like mental math and just kind of doing it on the side, your calculations, that's not enough. That won't count for written work. Okay, so I need you to get used to putting in an equation, line up your equal signs so you keep it neat. And then here we're going to end up with our final amount, which is E, right? We're going to solve it. And we're going to got one student already done with it. Let's see if I can, 2,000. Nice. A bunch of students have it. Evie got it. Noah got it. Ava got it. Good job. All right. So in 4 years, it's going to cost, well, look, this is what I got, but why do I not leave it like that? You ever seen a price in a store that has 819.2? That would be crazy if like there's a new store and their thing was that they have no pennies and all their prices were like this. I think that's like a gimmick. I think people would go there. They'd be like, I never have to pay for the pennies. You got to put the zero there. This is money. Make sure it looks like money if you're talking about money. All right. Thumbs up, sideways, down. Do you see how we're doing it? You want to do one without these steps? Just go right at it now. Yeah. All right. Take a screenshot if you need it. I'll give you guys a moment to do this. This is number 12. And your screenshots have your time. It tells your timestamp, so it should let you do that. Okay. So I see that we have just a moment left in class. I want to do this last problem. I will do it warp speed. So I'm going to move this away, screenshot in 3, 2, 1. Okay. So let's look at 16 really quick because that was our last problem. And it didn't have any of those steps, which I think actually makes it a little straightforward. So let's do number 16, last one. And then you guys are out. Lunchtime. All right. So in 1970, the comic book equals 35 cents. It only costs 35 cents. All right. It appreciates. Appreciates means it is growing. It goes up in price. Appreciates value 10% a year. Okay, we'll change that into a decimal just so we're ready for that. Then I know what will it be worth. So worth in 2020, which I look at that 1970 to 2020 is 50 years. Okay. Now I'm ready to round to the nearest cent. So let's write our equation that we always use, 1 plus or minus r to the x. And my initial, how much did it cost to start? 35 cents. Let's see, we knew we had appreciation, so it was a growth. So 1 plus. The rate is 10 cents. 50 years. So let's go ahead and keep it nice and neat, just like your work moving forward, 1.1 to the 50. And we're going to get it right away right here. So see if you can work that out. Show it in the chat. That will be our last bit, and then I will dismiss you all. So let's see, 1.1 to the 50. All right. Show me to the nearest cent, to the nearest hundredth cent. Remember, do this first. Because PEMDAS says we do exponents first, then we multiply. All right, final moments. Nice. Noah, perfect. Perfect. 41.09 in 2020. Look how much quicker they are with all those little baby steps. We write down the information. We do the change with the decimal to or percent to decimal. We know it's growth. We know how much we start with. We know how much time we're going to do. And that's what we just plug in. There's always only 3 things to plug in. So keep that in mind. You might be like, 3 things? Yeah, only 3. We could do that. And then it's calculator work, right? Okay. All right, thumbs up, sideways down. I know it's your lunch. Let's just check in real quick. Pretty good. All right. All right. So you guys are dismissed. This is third period, so I will wait. This is third period, so I will see you tomorrow. Okay. All right, guys. Take care. Evie, if you want to stick around for a second, just to look over those 2 problems, I can have it ready. Let me get it ready for you. All right. All right, guys. Take care. Let's see. So you had asked about the last assignment, which was 1, 2, 2. It was 1, 2, 2. Where is that? Looks like I gave you. Oh, there it is. All right, that is in the workbook. You want to just see the first 2 to see if you got it on the right track. All right, let's see. 1, 2, 2. All right, I'm going to go ahead and stop the recording though.